You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you. Hello, this is Richard Jacobs with the Future Tech Podcast. I have Greg Paulsen. He's the head of applications engineering at Xometry. It's spelled Xometry.com. That's their website. Greg, thanks for coming.
Hey, really happy to be here. Thanks so much.
Yeah, so what is Xometry? It sounds like some Frankenstein monster of geometry.
Yeah, so I always like the idea when you're, trying to name, you can either name it like literal, like manufacturing services on demand or something like that, or you can build
That's
a name.
Boring, yeah.
Yeah, build a name and then give it identity by, actually doing the job so well that they're like, that's Xometry there. And what we do is we make manufacturing easy for custom parts. And we've done this by revolutionizing the kind of established manufacturing industry by adding tools like AI, machine learning, a new concept called manufacturing as a service, and kind of combining it all so that for a customer, they can procure parts in one location, yet still have this ability to take advantage of the talents of essentially a gigantic manufacturing network of thousands.
So what are some of the challenges, the things that you're helping people to overcome?
Yeah. So this is, I like to call this the pain of procurement. Traditionally, and this is by traditionally, I mean, even like 5 years ago, this is why this is so different. Is like, 4 or 5 years ago, and a lot of companies still nowadays, when they need to source a custom manufactured part or a finished part, a 3D print, something like that, they typically do this shotgun approach, where you're working on a local basis with maybe a list of 4 or 5 folks. You're creating what's called a technical data package, and you are taking those files, maybe a drawing showing what the files needs to be, and a spreadsheet that says, please quote quantity 1, 5, 25, 50, 100, and you BCC chain this and shoot it out, and you wait. And during this wait, you may hear back from them, you may not. And sometimes it takes several days to hear back. And sometimes when you hear back, it's not even what you're looking for, really. It's when do you need them by, or it's another question. And we came with this idea at Xometry to put technology right up front. So instead of that, what we call the RFQ, right? The request for a quote. What if you just got pricing right away? What if by using essentially a interpretation of the model and market-based pricing that we've generated over time, we've allowed a customer to basically upload that file and boom, have a price, have a lead time, and then continue to configure, and the price and lead time just will naturally update. So if you add quantities, you'll see price breaks happen. And we do this for not just a technology, but a portfolio of common manufacturing technologies.
So how do you do this? How do you provide, projects can be complex and very different and varied. So do you have a network of manufacturers with capability that are somehow, are you providing quotes in an automated way based on knowing the rules and capabilities of manufacturers? Or is this where they have to look in like a forum type system and say, I can do that job for this much and bid against each other? Like, how does it work?
Yeah, so it's not a bid system. That's what makes us really unique. Is usually a bid system. If you're a supplier, you're paying a procurement. One is finding clients, right? And then the second one is you're in a competitive area. So you may have your sweet spots where you are always a winner, but there are also things that you can do. But there may be other people that have their sweet spots there, and you just don't know. It's one-sided blind for you. And same with the customer, by the way. They don't know what you're best at either. So what we do is a twofold system. So the first is, as you said, the pricing. We've actually taken the data and feedback loop of us essentially pricing out parts, getting the work, and then using a network that we've established over time that has now grown to thousands of manufacturers, giving those manufacturers work at a price. And based off the price that the manufacturers take that at, it's become our feedback loop. And we have done some really interesting artificial intelligence and really state-of-the-industry research to determine what we call a market fair price. So we don't need to see the part beforehand. The part, it may be the first instance of this part ever will see the world, and you can upload this, and our system will interpret the geometry, determine based off the manufacturing process selected. If not, we'll default to the cheapest process, which is typically a 3D printing process. It will go and give you a price and lead time, because it's basically saying this AI is going and saying parts like this with this shape and this process typically cost this much on a competitive marketplace. And that is the price that you see. So you see this kind of buy it now, fair price that can be distributed across, a marketplace.
That's cool.
Yeah.
Mm.
And
have you noticed that there's a difference that the price you're able to get for people is even lower than what they would get, searching on their own in addition to a shorter lead time?
Yeah. So this is the beautiful thing is when you add, so like this is called manufacturing as a service, because we are this platform, right? We're a central, as a service platform where both customer and provider are using the same platform for their work. So it's this central location, but we get to know a little bit more about each. We know what the customer's type of work they're looking for. Obviously, like they're specifying this work. And then we also know what our provider sweet spots are. So it starts off with this manufacturing provider putting in information, kind of like a profile, but we also learn more about them, about like what type of work they're taking and what we think the match will be. So we're actually able to offer a more competitive pricing to our customers than what they would get via the shotgun approach usually, because we know the sweet spots of these manufacturers, and we're able to essentially give these manufacturers projects that they actually really like to make. And so they can usually do that cheaper and quicker, which allows us to go across a broad range of technologies. And Xometry has about a dozen technologies that we offer. So when I talk about that, I talk about like CNC machining, sheet metal, injection molding. I have 7 different types of additive manufacturing, urethane casting.
Well,
I'm probably forgetting a couple there.
For people that don't know how things are made, like me, I don't know if I look at a part, it's urethane casting. What are some of the common things that we see in our everyday world, and what are the methods used to make them, for example?
Well, yeah, absolutely. So it's really interesting because you're seeing, I'm sitting in front of a microphone right now. I have my laptop, monitor screens. A lot of what you're seeing there is injection mold, and that's typically more of a, mass produced. We're talking, orders in hundreds of thousands to millions of units, right? And injection molding is this process that is highly scalable because you put everything into a fixed cost, usually a steel tool. If you're prototyping, sometimes it's an aluminum tool. But this tool is essentially the negative of the shape that you're going to make out of plastic. And you'll close that tool up, inject it molten plastic in, it cools to shape. The tool opens up and you have a part. So that price to kind of close, inject that material and open up is very, very cheap. So it allows these processes to scale. And that's really great when we talk about, again, my computer mouse. But a lot of our world is custom. So when you go away from this massive manufacturing need to something that's custom manufacturing, usually that amortization, that scale gets a little bit more skewed because that upfront setup may all of a sudden show very high. For example, the cost of that steel tooling may show very high compared to the overall project, especially if I just need, few hundred made or, 10 or 12 for that. So when you look at custom manufacturing, a lot of times, probably the best example would be something like an aerospace manufacturer component or a medical device, where there's still a need for high-level specification, things like complexity and geometry. But I'm throwing this into space, right? Or this is a part of a device for a particular type of surgery or a particular set where the quantities needed are not as high.
Right.
So custom manufacturing is a little bit more of an interesting beast because it's not quite going to that full contract scalability, but it still is a very high demand because a lot of the work around you, like that 99, of that world, like you have maybe a few hundred needs, but the parts still need to be as good as something that's going to be fully contracted manufacturing, and we're able to find the right supplier for that and compare and connect them.
Okay, interesting. I was picturing when you're talking about injection molding, when the piece comes out, does it have plastic hanging off of it, like burrs or things like that? And I know from talking to people about 3D printing that sometimes the finishing of the product is a real pain, and it makes the 3D printing not nearly as economically viable. So does your system know, depending on the geometry of the part, not only will this method be, let's say, the fastest and the cheapest, but it has the less requirements for finishing of the part, or it has the tightest tolerances? And we know this is an aerospace part, so you're going to want this method for myriad reasons, not just as one thing.
Yeah, and that's where it comes to strengths and trade-offs. So my experience as an application engineer is kind of that consulting role, and I work with customers on a daily basis to help them determine what bets to choose. So when you talk about 3D printing, I think 3D printing is an awesome subject to touch on, because in the past, and I mean up to this day, it's still extremely viable for prototyping. In fact, that's what it's been best known as. But what many don't know is that it's now being highly utilized for this low volume production need very often, because the price per unit has become much more commoditized in the last decade. Especially with processes like laser sintering, which will actually fuse a shape in nylon using a laser and kind of a nylon powder bed to make this 3-dimensional shape, where you could stack a bunch of parts in a single build, getting a better economy of scale. But even processes where you're layering parts up with, say, a melted filament. So if you imagine those desktop 3D printers, there's industrial versions of those, and that's called fused deposition modeling. Even over the last few years, that pricing has gone down and the quality of the prints has increased. So a lot of times we found viable substitutions for what would usually be a much more expensive process to make parts using things like 3D printing. And with this site that we have at Xometry, if you have a 3D model, it just requires an upload to go and click and compare and see what the price changes will be based off your quantities, because there may be a scaling difference. Quantity 1 may be cheaper in this, quantity 10 may be cheaper in this option. To your point about finishing, we have, not all 3D printing processes are the same, right? So if I'm layering with a filament, you may see that zigzagging type pattern. So layer-wise, we kind of call those layer lines or stair-stepping, which show more on gradual contours. But if I go to a process that may have a base material that is actually liquid to start. So we have a couple resin-based processes like stereolithography and a process called digital light synthesis by a company branded Carbon. Those actually have much smoother transitions. They look more like what you would have for the traditional molded part be, because the base is this liquid resin that gets cured up and hardened on a layer by layer basis, kind of building that geometry. The trade-offs with those very often are not directly a thermoplastic. So when I talk about injection molding, a thermoplastic is something that will liquefy over intense heat. It'll become plastic with heat, so thermoplastic. And a lot of these become more of what are called a thermoset, which is that they have a reaction that causes them to harden in place. Good example is a urethane or epoxy. So if you're used to epoxies, you take this material as they compound together, they set in place, and they have a little bit of that external heat reaction to them. But it's beautiful for 3D printing because I could cure these really intricate shapes without needing to do this complex setup. Like the printer will just print what you give it. and you'll get these out. And the advancements now are, instead of being like the advancements in setups and these fixed costs, the advancements have now become material science advancements. So like carbon.
So what is the what's the, you have this great system and you found economies of scale, you found sweet spots for manufacturers, you found so many cool efficiencies. Like, what is the ultimate system you'd envision? What are like all the things it would do?
Yeah. So this is, we have these discrete manufacturing processes, and we make really great parts very quickly and easily. There's still a giant marketplace out there where this transactional cost of sourcing is still huge. So it's not just for someone who's a customer, potential customer, a designer, an engineer, a procurement person looking for a supplier, but even suppliers need suppliers because they may not have everything in-house, like, for example, finishing. So if I have, I create a copper part, but I want to make sure it doesn't corrode over time because it's an electrical conductor, I may gold plate that. So I may need to use a plating service for that. So Xometry has expanded. We first started with our reach in the United States, right? We have a U.S. manufacturing base. We've had a couple acquisitions along the way as well, and we're actually expanding to Europe as well. But we've expanded like our actual geographic location and the amount of manufacturers that we have available. We've also expanded the venues in which these manufacturers can interact with each other. So we recently released something called the Finishing Services Network that manufacturers who are they're not getting turnkey parts from Xometry directly can still actually access a network to get secondary services like post-processing, finishing done in a very simplified manner. So still like a one single portal, able to connect, with a plethora of manufacturers out there and get information back in order to get a successful project. So that transactional foundation for manufacturing is what we're really enhancing. And we're doing that again with the AI machine learned options. And we're making it very quick. We're making it very intuitive. And we're taking away that opaque, the opaque nature that it used to be, where you're just blindly sending it out and you're kind of blindly hearing back and you don't know why a price comes out a certain way. Like we're trying to create full transparency in the entire transaction process of the supply chain.
What if I was to want to make a part, and so right now you give me back the best thing to do with it, the best price and all that. I mean, what if you gave me back a range of options? Like what if I said to you, all right, I know there's trade-offs. I want to get this for the cheapest price, but I also want to have the least finishing work, the lowest lead time, the greatest interoperability, the best wear, the blah, 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 I wanted like 20 different things. Can you give me back 4 or 5 paths for this product so I can evaluate back in my shop, all right, if we do this, this is what we'll get. If we do that, and do some planning on my end.
Yeah, absolutely.
Really sophisticated,
Yeah. So, I mean, the site itself will do 90% of that work. So just going on the site and uploading your model, you can actually upload the same model multiple times over and essentially just put different processes in, and you'll get that feedback right away. So you'll get that, pricing trade-offs, that information. Something that I also work on is kind of like the guidance from our actual in-person technical engineering team. So we have a application engineering team that you can work with and kind of have some discussions on kind of like what you're talking about. Like, I want this, but I also want this. And so we will help kind of find that middle ground or the optimum solution for you. And of course, we also have built free design guides, resources. I do a lot of videos and webinars on this subject as well. So we're really trying to create a knowledge nucleus, like an entire ecosystem around manufacturing knowledge beyond just spitting on a quote and giving you a price. We're trying to actually make you an informed customer and build that out. But yeah, the site allows you to do all these options at once. In fact, actually, BMW, who has been a customer of ours for quite a while and is also an investor of Xometry, they actually invested after being a customer. They actually use us for tooling options. So they make jigs, fixtures, and other tooling that they're using on their production line in their American plant. And these jigs and fixtures very often are multiple technologies in themselves. So in the past, they may have sent this out to multiple providers, and from their supply chain side now have to, juggle a few different providers, getting this, maybe this CNC machine part over here, getting this plastic 3D printed part over here, and then having someone maybe do the assembly for them. We are able to actually take that all as just one order, and maybe, 2, 3, 4 different technologies that are just in this assembly alone. And we're able to basically kit, integrate, and get this manufactured. And we are now consolidating that entire supply chain to just Xometry. So for them, BMW, they're huge. You have a vendor procurement list, right? You have to get approved suppliers, and it's much, much easier for them to approve Xometry, and then at one click have 3,000 manufacturers than approve 3,000 manufacturers. And so they love us for that. And yeah, we've, GE, Bosch, Dell, they've all been customers who eventually have become investors of Xometry as well for that kind of same reason. Like these guys are huge. They have massive supply chain needs, and they see the value add that happens when you add modern AI, modern machine learning to, again, this very traditional supply chain where it's like, I hope you have room for this. Can I throw this part on your machine? And sometimes the answer is like, in 2 weeks, yeah. And we don't like that. We like to work everything in parallel.
I mean, how many different manufacturers are you plugged into in terms of knowing their capabilities and sweet spots and all that? I mean, so
we're around,
how many?
We're around 3,000 manufacturing base right now. And we've added more with the acquisition in Europe as well. So we just actually acquired Shift.Parts, which is now Xometry Europe, and we're really excited about that expansion.
So what percentage of the manufacturing market is that, in Europe and in, I don't know if it's the US or the other place, but
I don't know the exact percentage. I will say that there's still a lot of room to grow. Small business manufacturing is, in aggregate, a very, very large business for manufacturing in the US alone. And it's often understated when you look at, a few levels up. Usually, like if you see a political spotlight or something, they're talking about these major factories, like something that works for a major automotive factory. But behind every single one of these major factories is a smaller supply chain of dozens upon dozens of small business manufacturers. Something that's really important, and actually something that I'm personally very proud of, working for this company for, is how we have been able to positively affect a lot of our small business manufacturing base by giving them work. So these are hardworking shops, usually sub 20 employees. Some of them are sub 5 employees, and a lot of times the owner is also the machinist, right? The best machinist in the shop sometimes is the business owner, and for them, they'll go onto Xometry's manufacturing partner network, the job board, and they'll be able to find jobs that can fill their capacity. If they have for example, seasonality, say they're in the oil and gas industry, they may have seasonality on their jobs. They're able to actually fill their capacity and get work to keep their spindles running while they have gaps between orders. Sometimes this becomes their entire business plan. We have a lot of, I think we're up to like five plus manufacturing partners who have done over $1 million of business through Xometry's manufacturing partner network. And that's a growing list all the time. We're actually, I think 2020 is going to be an amazing year to see a lot more of those manufacturers come about. We've only been around since 2014, and building out the success of our manufacturers. Sometimes their problem is no longer finding work. Their problem is growing. Like how do I manage the growth of my company now, and actually like really elevating, because now we're adding jobs to American small businesses, and it's very exciting. And some of the stories that we see and that we hear from our manufacturing partners are just very moving.
Well, the thing is, at some point you'll have an overview of the manufacturing industry that no one else will have. You'll know all these different, these companies, what they can do, what they like to do, where the holes are, where the lack in production capability is, etc. So that intelligence is, it's a very powerful thing.
Yeah, and I think we've seen this all the time with big data, machine learning, is that a lot of times the opportunity exists, the connection doesn't. So by adding this, we're actually connecting what's the customer, what their project requires, with those best to complete it. So we're actually connecting that open capacity and talent with the project needs. So we're able to hit the scope, the price and the lead time by using this approach. And it's really exciting because there's a few ways to kind of grow a manufacturing business. And, for us, it's making more capable platform, making more intelligent technology solutions within that platform, and kind of streamlining the whole process.
Interesting. So what are some of the limits? If I want to make just a prototype, should I talk to you guys, or is there a better place to go? Or, if I want to make 100 of a certain part, is that when it would be effective to go to you? Like, what's your market look like?
So we have no minimum quantity. So actually, prototyping is still a large part of our business. I kind of joke because I come from additive manufacturing, applied additive manufacturing, and by part count, additive is king. Where we are doing a bunch of piece parts and even small volume production with additive manufacturing technologies. Both plastics and metal additive manufacturing. But by revenue, a CNC machine job is still, more expensive because you're paying for that talent, you're paying for, the setup costs and the milling of those parts. So the raw goods are a little more expensive there. So by revenue, machining is king. Machining and sheet metal are still, very strong in our base, and that's something that we've found a lot of talent in. So who's coming to us is usually, again, from that prototype and conceptual modeling stage. So a lot of that's going to be 3D printing and building up a iterative design process coming through. We have 3D printing technologies can be used for end use, and sometimes you just need 3 or 4. Fantastic process to use for those low volume but end use requirements. But we can also scale. So because we have this expansive network, we're able to go from, say, a 3D print and then move to, higher fidelity print for fit checking, and then move to something like injection mold. So like what I described earlier, where you're able to then think of volumes of thousands. You can move in that direction fluidly with Xometry, and we can help work with you as you scale up. And sometimes that includes that kind of consultation interaction between your design and the process you're looking for. So that's where we really focus on that knowledge is sometimes you have to modify, actually almost all the time you have to modify your design when you scale, because every little bump, every little nudge, every little thing that may cause a few seconds interruption in manufacturing is going to cost, a lot of money over scale. So we're really there to help communicate that through.
Are you the nicest guys in the manufacturing industry? Sounds like.
Well, it's because we're not sitting there with a spreadsheet all the time quoting. I like to think that we're able to focus more with the customer and kind of learn more about their project. So I've enjoyed it because I've been the guy with a spreadsheet quoting before too. And when you're spending 80% of your day for projects that you don't know if you're going to win or not, that can be challenging. So for me, if as a supplier and buyer, in a lot of my cases, the fluid nature of the whole process and transparency up front is absolutely fantastic and allows you to really focus on the service end of manufacturing.
Well, I mean, even if I have a company and I'm manufacturing something for a long time and now I'm ready to scale, again, you can step in and help me. Because you could say, hey, I know you're making it with this method, but you change to this method, here's the trade-offs, and it may help you scale. And if you that kind of stuff.
Yeah, a lot of times I ask this question, which is, where's your project in 6 weeks? Where's your project in 6 months? And where's it in 6 years? Because a lot of times that there's different goals, right? Sometimes it's quick internal testing. It's what we call like on the engineering floor. We have something where I'm gonna probably get the part, but very likely I'm gonna take a drill bit and drill in here and sand and kind of modify this as I work through and maybe get a few iterations through to validate. And then I may go to market testing where I have an idea what my market is, but I don't quite know what it is yet. So I may find a bridge method. So when we talk about bridging, it's usually a method between that prototype and whatever the final production is going to be. And sometimes it's that final production method, like a bridge tool, but it's just a cheaper way of doing it. So a tool that may really only be good for like 25,000, 50,000, where ultimately you may move up to something that could produce millions. But you're going to be an order of magnitude cheaper going this direction first, and you're able to validate the market and figure out if you need to change your design or if the market exists and work that through. So we have a lot of ways of kind of staging out and talking about those trade-offs as you're working through your design and your process and connect through. And it's, I think that's one of our strong points is that have it your way approach, because we have all these options. We're not just trying to sell a single brand because that's the only brand we own, right? We're trying to figure out what your needs are and look at our portfolio and find the right solution.
That's pretty cool. Excellent. All right. So what's the best way for people to get in touch? So they just go to Xometry.com, or is there more preferred methods?
Yeah, the website, I say the quote site will sell itself. So Xometry.com. If you have a 3D CAD model, you can upload it right away. And like I said, that price will show up immediately, and you can start playing around with different, materials and processes. My name is Greg Paulsen, and I'm lead our application engineering team here at Xometry. And if you guys do Twitter, I'm Xometry Greg, and you guys can find me on LinkedIn as well. But I'm always happy to talk about project needs and make sure that you're connected with the right person to help kind of guide through. We also have some really cool resources on Xometry's site. So even if you don't have something quite ready to quote, I highly recommend checking out our resource page for the design guides, some really cool videos. We have recorded webinars, we have FAQs. There's a lot going on around that knowledge base area, and that's something that we're really strong about is building a better knowledge base. So because we want you to be a better designer, it's better for everybody. Manufacturers like to make your parts more, you get better success out of it. So we have a lot of resources available around the entire design part manufacturing community.
Well, that's excellent. Well, I appreciate you coming. It sounds like, you guys sound extremely friendly and helpful, and you've got a lot of great capability. So it's a magical, good mix. I think I wish I had things to bring to you, but maybe I do. I don't know.
It's exciting, and I think Xometry, just in general, from the future of supply chains. I mean, there's a lot of stuff that has supply chain deficiencies where what I'm talking about for getting a custom part is very analogous for other things, in the health field and just in general getting stuff field. It's like and I think Xometry is one of these leaders where they're looking at this movement of building a central platform, building a qualified network and ways of qualifying and monitoring that network for quality control. And all this stuff is very analogous for other industries where they may be ripe for essentially a technology disruption.
Okay. Well, very good. Well, Greg, again, thank you for coming. I appreciate it.
All right. Happy to be here. Thank you so much.
You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you.